basically have the same process, just little nuances between the two. And I wanted to have a comparison so you all can see exactly how one works compared to the other. Can y'all see this up here? We can turn more lights on. Everybody okay? All right, so here we have a cross section of the male pelvis. So here we have the bladder and the rectum right here. Now here we have the prostate gland. Women do not have prostate gland. Prostate gland has kind of two functions. One is to help keep us from urinating in our pants. Quite frankly, it helps control urine, but also helps control. I can see this.
It's only fair that we get it sometime. It's only fair that we get it covered sometime.
Also helps control the release of semen. Kind of works like a two-way valve. Now I'm doing it. It kind of works like a two-way valve. So going through the prostate gland, you have what's called the prostatic urethra. Right there. Then back here, about halfway through the prostate gland, you have what's called the ejaculatory duct. The ejaculatory duct connects to what's called the seminal vesicle, right back here. Here we have the testes. We talked about that a little bit a few weeks ago. Vas deferens or ductus deferens, which transports the sperm from the epididymis when the sperm starts to mature and makes its way up through the vas deferens to the seminal vesicle right back here, where it stores and continues to mature until ejaculation. Now, during arousal, start normally right now, all you guys, this tube right here, the prostatic urethra, will be open to some degree. You have a small sphincter right up here, and you have an internal urethral sphincter right there. And this ejaculatory duct is closed. Now, during arousal, this portion of the prostate gland closes off, and the ejaculatory duct opens into the urethra. The prostate gland has a parasympathetic nerve network surrounding it. And that parasympathetic nerve network causes the prostate gland to change shapes during arousal. So this portion right here closes off, this portion opens up. And that way, whenever you release sperm, they make their way down through the ejaculatory duct into the urethra, and eventually out to the end of the urethra. Here we have the bladder, ureter right here, and the rectum right here. Here is our rectovesicular pouch right here. Obviously, we don't have a rectovesicular pouch in it, guys. So there's a little pouch that we talked about a few weeks ago. So now the penis. Now I know this may make some of you guys cringe a little bit. This is a cross section of the penis. We actually used to do this in the prostate. We have the cross section. But the penis has three separate, distinct tubes. You have the two tubes on the dorsal portion of the penis. Now, the doctor, who would do that? Has anyone talked with you about anatomical position?
Yes.
A little bit, okay. Has Dr. Lunsford, I guess, is one who have done that with you?
Yes.
All right. Did he talk about anatomical position in relationship to the penis?
Yes.
Okay. If you look down right now, you're going to actually be looking at the dorsal surface of the penis. Ventral surface is actually right now, if I'm standing here right now, the ventral surface is actually to the back. The way to keep this straight, the little head points to the victim. That's anatomy. So when I'm talking about the penis, this is the part which, so this is the dorsal surface, this is the ventral surface. So back here we have, this is called the corpus cavernosum. That is the erectile tissue. arousal, this artery right here, the deep artery of the penis, dilates and allows extra blood to go into the corpus cavernosum to cause erection. Then you have down here the corpus spongiosum. This is not erectile tissue. This contains the urethra. The corpus spongiosum actually makes the gland or tip of the penis. Then you have, surrounding all this, you have the deep fascia of the penis, and you have everything segmented. You can't see it real good right there, but there's a little septum in there as well. And that keeps everything nice and separate. Then you have the superficial and deep dorsal veins. Right up here you have the nerves. We're going to show you, I'll show you where those come from in just a second. And so finally we have the skin on the outside, and it's showing this kind of connective tissue. It's yellow, but there isn't. It's just a little bit of loose connective tissue. So it does allow the skin to be able to move a little bit between that and the deep fascia. All right. So back before there were medications that you see advertised on TV every night, before there was Cialis and Viagra and all that stuff that was readily available, guys who had a problem with erectile dysfunction, would actually have this surgically removed right here on one side. And they would put a penile implant in there. Couple different types. One of them was like a balloon. So you had behind the scrotum, you had a little air valve that you pumped it up. And you literally pump it in, come right up. Then there's another valve back there to push to release the air to make it go down. When I was taking this course, we actually still used cadavers, and we had cadavers that had one of these things. And we actually had to learn how to use it because somebody pumped it up and left it pumped up. Because, probably Dr. Ashenville, that's the kind of thing he would have done. So we had to go look it up to find out how these things work. There's another option that you will see, that these things have been, this has been removed. They use this thing as kind of like the reading lamps that y'all have on your desk and wiggle around like that. You have a reading lamp. So it's kind of like one of those you win. Now, the reason I'm talking about these, because you will see these in practice. Some guys, despite all the pharmacology that's available and all, the pharmacology just doesn't work. So they use these implant devices. And if they wear one, have one of these things, it will show up on X-ray all day long. And my advice to you, if you see that on X-ray, don't say a thing about it. Just move on. Know it's there and just move on. But if you don't take X-ray, a lot of times you can get one. You won't know it's there unless they tell you. Some guys will tell you, some guys won't. So the point I'm making is it's hard for these guys with these implants to lay on the trunk because things don't flatten out like they would if you don't have one. You guys don't call much of them, you know everything. If you got one of these implant devices, you won't. And you can actually injure the patient if you're not careful about this. And if you don't know about it, it's on kind of a little bit on them if they haven't told you. How many of you have ever seen a drop tube? Just okay. The bottom piece has a little notch, or a half circle notch in, right? Called a male cutout. It's to accommodate the male genital. Why think? But if you're dealing with one of these things, you probably better open up that little piece a little bit more, just to give them more. Now, if you're just using a flat bench, I don't know how much you can do about that, but if you're using a flat bench, most likely you're doing side posture, low back, and pelvic adjustments anyway. So it doesn't matter what you do. It probably wouldn't matter as well. But you will encounter some of these things. So just be aware that they are out there. And when you see it on the intake form, just make a mental, I wouldn't even say anything about it. Just make a mental note. Just make a mental note that that thing is there and be aware of that whenever you're working with the pelvis for a little back. Because you can pretty seriously injure the guy if talking about the muscles of the perineum. We had, remember, the ischiocavernosus muscle, the bulbosponginosus muscle, and we had the superficial and deep transverse perineal muscle. Now, the penis, we had talked about the other day, we had the crus or crura of the clitoris. Penis also has the same structure, and obviously a little bit more in depth. But here we have the left and right crus of the penis. And they become contiguous with the corpus cavernosus. They are underneath the ischiocavernosus muscle. And then we have the bulb of the penis. That becomes contiguous with the corpus sponginosus and eventually the glands. This is covered by these bulbosponginosus muscles. Now, in guys, obviously, we don't have it over there. And of course, back here we have our superficial transverse perineal. There's our perineal body right here. And the membrane, you can see a little bit better here without the musculature in the way. There's the perineal membrane. And back here would be your external anal seal. So here we have just comparing the two. Y'all can take a look at that whenever you get it. All right, so there's another little closer up picture of everything. Now at this point, we are adding in this gland right here. We haven't talked about it yet. That's called copper. It's very similar to the vestibular gland in females. What that does is add bicarbonate and lubrication and fructose to the semen.
Professor,
Yes.
what did you say it was called again?
Copper gland.
What? Toppers?
Cowper's gland.
Cowpers, thank you.
So what it does is add the fructose, the bicarbonate, and the lubrication to the semen. The vagina is very acidic. Y'all would never know it, but it's not as acidic enough to feel like sperm. But it's very acidic, protects you ladies from foreign invasion, including as far as your body is concerned. Sperm is foreign invasion. It's not yours, it came someplace else. So what this does is copper gland secretes this bicarbonate, which helps neutralize the pH of the vagina. So the sperm can make their way up eventually to the cervix and through the cervical canal. Now, sperm, I'm going to show you a picture of it in a minute. Sperm have mitochondria. And are y'all taking biochemistry right now? Have y'all talked about mitochondria yet?
Yes.
Okay. So mitochondria produce ATP, right? Either aerobically, which is the way most of them do. And to have aerobic metabolism, you must have anaerobic metabolism as well. So the copper gland produces fructose, which breaks down into glucose and eventually allows glycolysis to go inside the sperm to produce the pyruvic acid so that you have PCA and eventually oxidative phosphorylation taking place so the sperm have enough energy to swim upstream. Now we're going to look at this right in here since it's labeled real nice. So here is our corpus cavernosus right here, going back here to our crura back here. Here is our corpus sponginosus. And you can see how the corpus sponginosus comes out here and forms what's called the glands. That is not the head. That is the glands. Now surrounding the glands right here, you have the foreskin. Foreskin is not disposable. The only reason to remove the foreskin is for religious and cultural reasons. That's it. In this country after World War II, the OB decided they wanted to start circumcising all the women. Just a way to tack on an extra couple $100 to the hospital bill, pretty much. That's no reason to do it. Unless you happen to be Jewish or Muslim, I'm not saying I'm sure. But there's no reason to do it better. The idea being, well, the little boy can't clean back. He doesn't need it. The foreskin is adhered to the glands. it stays adhered to the gland until the kid is back up to 3 years old. And then at that point, it will roll back. And at that point, if the little boy needs to clean back there, you can roll it back and certainly clean up under there and wipe everything out, and everything is fine. But to that point, it's adhered right here. So nothing can get back in there and cause a problem. Only time that you run into a problem is when you have, say, somebody that doesn't really understand. So you're going out tonight, get a babysitter. Babysitter doesn't know he's circumcised, or not circumcised, pardon. Or if she does, or he does, they don't know what to do about it. So they're cleaning him up, he had an accident, clean him up. And they decide that they're going to force that foreskin back and clean underneath. Now, if that occurs, that foreskin prematurely, that foreskin can get hung up right here. That's called the corona. And it can get stuck back there. And it can cause a decrease in blood supply to the glands, and it has to be removed, or it will back and that's a very serious problem going down the road. That's the only reason to do it that way. Most of the rest of the world does not do that. Just here in the United States, and started doing it after World War II. I know there's any big reason to do it. Because they want to make more money for this. Kids who are born home don't really naturally have not been circumcised. So just something to be aware of. It's none of my business if you're ever in that situation, what you do or don't do, none of my business whatsoever. But I just want you to know the reality. I'm told that there's a ton of nerve endings in you. So removing that may eventually down the road end up leading to loss of sensation. And you think about ED nowadays. You hear about that all the time. And you wonder how many of these guys are having a problem with sensation because they were circumcised. And something to think about. Because we didn't do it very recently. And so here we have. I'm sorry.
Some of the children that don't get circumcised, it may not roll back when they get to be 2 or 3, and then they have to get that surgery.
Occasionally they have to have it done, but
It's not
very rare.
traumatizing things. I think that's why, and I've been in on some of the circumcisions, and they don't do it really under anesthesia, which is not terrible.
No anesthesia.
But when they take it off, when they do the circumcision, they're just taking off the little tab. Later, when they do have any problem with bacteria getting stuck in there, some people don't even put it done until they get older. They can travel with the hospital and keep the insurance and other kind of companies.
That's certainly a personal choice. So, let's see. Now let's kind of move over here and talk about the scrotum. I mentioned a little bit of this back when we talked about the abdominal wall just a little bit, because the layers of the scrotum are contiguous with the layers of the abdominal wall. And if any of you guys have ever been hit in this area, first thing it feels like is that your stomach is turning into a big old knot. And here's why. These layers, I got a little slide here, second, show you what's contiguous like. But here we have our tunica albuginea. That is the white covering on the outside of the testicles. Here we have the epididymis. Epididymis is where the sperm goes to mature. And it takes a few weeks for the sperm to mature. Sperm from the epididymis cannot get a form of pregnant. It is not fully undergone all the things involved in maturation. So then the sperm, once it's hung, hangs out here for a couple weeks, will make its way up through the vas deferens. Vas deferens does have a slight bit of smooth muscle, which means it does have a little bit of peristaltic action like this in the middle that helps force the sperm up to the seminal vessel. And it still hangs out in the seminal vessel for a few days. ejaculation. So it's not, as soon as it ejaculates, it can't really get a woman pregnant either. It has to go through a process called capacitation to allow for the sperm to actually be able to get someone pregnant. Okay. There's just a nice little frontal view of everything before we start talking about the testes more in depth. Right. So here we have everything up nice and close. So we have this spermatic cord. I think I may have mentioned that kind of in passing with the abdominal wall. The spermatic cord contains a muscle called cremasterix. Cremaster muscle elevates the testicles, and it is an involuntary response to different stimuli. Cold will cause that to happen. You guys know what I'm talking about. It's going out on a cold morning, everything kind of grows up a little bit. Also, in response to fear or some sort of anxiety. Because if you're running, it doesn't make a big of a difference now, but back, say, 500 years ago, 800 years ago, we'd run around, no clothes on, especially people from warmer climates, have very little of any clothing. And you're running around out in the jungle. You don't want to put anything hanging down that potentially gets snagged on a tree limb or whatnot. So, the cremaster muscle will cause the testicle to elevate up against the perineum. You also have a reflex called the cremaster reflex. It is the L1 superficial reflex. So what you do, we'll learn about dermatome. Dermatome is an area of skin that's innervated by a specific spinal nerve. You'll learn about that. L1 dermatome is roughly right at the top of your thigh, right in this area right here. So you stroke the inside of the thigh, and the testicle on that side will elevate in response to that stimulus. You'll learn about that more in the second quarter of the you'll change. But you'll learn about that whenever you take neurodiagnosis with Dr. Ames. They'll go into more detail. But you mostly use it in folks who are quadriplegic and paraplegic, because you want to see how much, if any, reproductive function they may have. Now, before you guys go on this afternoon and stand in front of your bathroom mirror and stroke the inside of your thighs and your testicles, you can't do it to yourself. It is a tickle type reflex, like you can't tickle yourself, right? So you can't do it to yourself, and I'll let y'all figure it out. This is mediated by the genitofemoral nerve. You have a genital branch of genitofemoral nerve. You want to know about the lumbar plexus and with Dr. Lewis. But you have a genital branch of genitofemoral nerve, which will cause mediate this reaction pathway. You also have in this genital branch, you have sympathetic as well as parasympathetic fibers. So the sympathetic fibers are there when you run into the jungle. Something is stressing you out. Things like that. Elevate testicles against the perineum. Cold will affect this. And the reason, I don't know, I got it in here in a second, the reason testicles are outside the body to start with is because traumatic incident takes place much better at about 94 degrees. So that's why we have the testicles are outside the body for increased thermogenics. All right, so here we have, covering the testicle, we have what's called the tunica vaginalis on the outside. Tunica albuginea on the outside. Albuginea is pink and white. And tunica vaginalis on the inside. The testicle, when you remove them from the cadaver, they look like a small egg. They are white. And then you cut them open, and you have this tunica albuginea right there. I couldn't remember when I was reading it. So the tunica albuginea surrounds the testicle and actually separates the testicle in scrotum. It's there, you may not ever be able to see it much. You have a ligament called the Goober neck. Testicles do develop on the posterior abdominal wall, just below the kidney. And right at birth, right before, maybe a day or time to after sometime, the testicles descend through the inguinal canal down to the throat. And the gubernaculum is what causes that descent. What it does is contract and brings the somatic cord and testicle all the way down to where it's supposed to be. Now, the ring is always there, but in an adult, or even postpartum, is really not much. Sometimes they don't, one of them doesn't descend properly. It happens in humans, but a lot of times it happens more so in animals. And if one of them doesn't descend properly, it just depends on the situation. Surgeon may go in there and try to bring it down. If it doesn't descend, what will happen is it will stay there on the posterior abdominal wall and just eventually end up dissolving. And if one of them doesn't descend, it's called crypt orchid. The term orchid is what you kind of use for reproductive orchids. They refer to orchids. So you will see that occasionally. Doesn't happen often, especially not now. If somebody has a problem, it doesn't descend, it usually really one of them. So here we have a close-up now from the anterior view. So over here, we have removed the outside of the somatic cord containing the chromaster muscle. And inside of the somatic cord, we have the testicular artery. Back over here, it's kind of hard to see right in there. It's got testicular artery. We talked about the testicular artery a few weeks ago. That comes off the abdominal aorta. Then we have what's called the panteniform plexus. So rather than just having one single vein going down to the testicle, you have this panteniform plexus. And I'll tell you why that is in a second. And then it eventually comes together out of here somewhere and produces or forms what's called the testicular vein. Left testicular vein drains into the left renal vein. Right testicular vein drains into the inferior vena cava. And then lastly, we have the vas deferens or ductus deferens. The two terms are used interchangeably. And that's what transports the sperm up to the seminal vesicle. So, what I mentioned a few minutes ago, how you have the layers of the abdominal wall are contiguous with the layers of the scrotum. So you have internal, external oblique. The only thing you do not have in the scrotum is camber faction, the fat. There should be no fat in the scrotum. If there is fat in the scrotum, more likely than not, you've had some sort of a herniation. So you can see right here, camber faction is not in. But scarpus fascia is. Scarpus fascia makes up the dartos layer of the scrotum. Dartos layer is what gives the scrotum its wrinkled appearance. That's also partly a protective mechanism. So the dartos layer has muscle in there, as well as fascia, will contract, also help to elevate the testicles up to the underside up against the perineum. And you all can read this out. Here we are a little bit closer in. So here is the epidermis. So we have the caput, the corpus, and the column. Forehead, body, and tail. And then the vas deferens comes off the tail, and you have this little convoluted part. That allows for the testicles to raise up and down. So you have kind of like a little spring almost, so that things can go up and down. And then you can come up here to the vas deferens itself. Arterial supply in here, and then here is the panteniform plexus. Now we'll make a little closer picture right here. So here we are on the inside of the testicle itself. So you have this tunica albuginea right in here. Tunica albuginea makes a little septa going inside of the testicle. And what it does, it separates all these little coiled tubes called the seminiferous tubes. So those things are all segmented, and that's where spermatogenesis takes place. Testicles also produce testosterone, right? So between these seminiferous tubules, you have what are called the Leydig cells, and they produce testosterone. And that's why we have this peniform testicle. So we have a larger surface area to absorb testosterone from that. Now, I was back up here. If a guy has a vasectomy, they cut the vas deferens so that they can't ejaculate sperm. Will that affect testosterone? Testosterone. No, because you don't do anything to the body. All you're doing is cutting to ejaculate sperm. You're not damaging anything, hopefully not. Anyway, damaging anything to do with the blood supply. Right, so let's come back down here. Then what happens is the sperm, the immature sperm, makes their way up through here, through what are called the afferent ducts, up here to the epidermis. And then they hang out here for a couple, 3 weeks, mature, and eventually make their way up to the seminal vesicle. All right, so here is a close-up of the seminiferous tubes. Spermatogenesis starts out here, and we're going to go through it in a minute, makes its way eventually into the lumen of those seminiferous tubes. All right, I was talking about this a little bit the other day with oogenesis. We're going to go back to this picture here in a minute and compare it. But here we have the interstitial cells of Leydig. This is actually a cross section of the testicle. I didn't do this. I don't know how to do things like this very well. But we can see how we are going from mitochondria to primary and then secondary spermatocyte and then spermatogenesis, which are immature sperm. Leydig cells, all interspersed throughout there, and you can see where the testosterone is. All right, so now spermatogenesis. If you read this week's material and last week's material, we talked about oogenesis and spermatogenesis. Oogenesis is the process of making oogenesis. Spermatogenesis is the process of making sperm. So oogenesis begins with. When does oogenesis start? Well, it's like 7th grade on. Puberty. Absolutely. When does oogenesis stop? Hoses are. Never? No, oogenesis stops at that point. That's okay. We can go back and look. I've got the last little bit of last week's material is actually set up to compare it to. And I guess it's time to take a break, so let's just stop right there. Before you do, let me take a pen and get your phones out because I have I changed things a little bit, and you're going to have to take a picture of the QR code. I'm tired of seeing 83 people check in or get people like this. Okay, so there you go. You should be able, if you can't, if you shouldn't, you should be able to get that picture. As soon as you check in, you go take a break. 5 seconds, so if you take a picture and then like check, you take another picture.
Yeah, you gotta do it through the app.
You gotta do it for the
Yeah, if you do it just from the QR code scanner, just do
you don't have to attend, you don't have to attend
I ran back in and I was in quick sheet. I need to watch the new season. I know. I need to watch it too. Yeah. Oh, there's also one that was saying I started last night. It's just so funny. I like the he's commentating. Yeah. Ooh.
Yeah, go set up a tent there for the week.
Morning, Dr. Martin. Hey, man, sorry I got confused on that email you sent me about my quiz makeup on Thursday. I think I just read it wrong. Yeah, I'm good to go. Yeah, that's fine. Yes, sir. Yeah, nah, man, I'm not doing that side. I'm on the male side of the PowerPoint, all right? Yeah. Sounds good, man. We're getting geared up to get you a little break for 2 weeks. Really? Where are you headed? Nice. You ever been there before? You know where Defusky Island is? That's my spot, man. I went to school in Georgia Southern, so we used to, and then I had a boat, and we would trailer it down to Savannah, and we'd all load up a bunch of college kids, and we'd run out there. And I'm like, yeah, ain't nothing better. I'm gonna go down to Desert. I'm gonna do my first offshore. I've never done offshore fishing, so my buddy, he got it for his birthday. Exactly. Yeah. My dad's the same way. He gets real bad seasick. What are you going to catch, Red? You ever done tail fishing? He was like, I said, well, are you getting to eat? I had no idea. He was like, no, you can't even take them out of the water. He was like, who the hell are you catching? He's like, you just get up to the boat and take a picture. I was like, and you gonna pay the guy $12? Is that right? Yeah. I mean, the video he was showing me, they were snapping out like cool, but I would be like, all right, man, I want to get it out. Right, yeah. But hopefully the rest will be hidden down there. My buddy, he still lives down in Savannah. He graduated from Southern, and he works for Georgia Power now down there, that power plant. And he goes just about every weekend. That's kind of his bread and butter. Yeah, just a little flat top. What's that? Yeah. He got 75 on the back. He just folds around in there. Man. Yeah. But not, what was that? I think it was the weekend we finished midterm. And I was like, man, I need a little break. And I took my boat. I had it up Lake Alatoona now. I had to bring it up here, like my parents and all. And I took it from Alatoona back down to Savannah for that weekend. We finished the Fusky. And I was like, man, I miss this place. Right. Still fun. Something about getting over there, and the only way to get there is by boat. You know what I mean? There's no cars or nothing. Yeah. Rent a golf cart, just go to drink. No, but I heard there's 2 courses. Right. It's probably, if I had to guess, underneath.
Oh my God, no, I'm loving that. I
You
love
probably get to eat live in the summer too. By the mosquitoes. Yeah, I didn't know you could play that. But my buddy said you can only walk the store. Right. See, because right there at Jabusky, you keep going down and you can see the lighthouse there, Harbor Tower there. I used to drop my anchor and we'd sit there and watch 18 holes. I watched Jordan, I think it was Jordan's beef and Fitzpatrick, that guy with the greats, and he did a playoff right there at that hole. Oh yeah, man. It was so cool, but then they started bringing in the Coast Guard because people were trying to go almost right up to it, and I was like, man, you can't do that. That's a safety risk. Yeah, I know, man. I was like, it's people, when you would anchor down, they try to like go around you with a trolling motor and then spot lock a trolling motor and sit there instead of putting an anchor, and I'm like, bro, you're going to get everybody, but we can't even do this. Exactly. They put it now where you almost, if you don't have young eyes, you have to have binoculars. Like my dad, he was over there like, what the hell? Riding around. I mean, I get it. Definitely a good spot and everything. And then so Thursday, what time are you going? 11? Yes, sir. Sounds good. Yes, sir. Hey, when did you quit using Canelo? Really? Is that because they did that patent trial where you basically just... I didn't have one. What do you like? You run that fast? Because it's real. Right. Yeah, my girlfriend, she actually just started PA school at and her first week was last week, and straight took it out. And I was like, hey, man. Yeah. But they're good on school. I think that's I didn't know based out of Philadelphia. I guess it's just like a subsidiary campus there. But I went with her for her orientation. It's nice. Yeah. Yeah. When I think about like what she's paying, I think total school and all is like right at 98 or 101. And I think about the year, and I'm like, bro, it's like 98.
It's an epidemic.
Yes. Yeah, dude. Right, sure. There's pros and cons to all of them. And she said sometimes they'll work with it, too. And it's just like a good going thing. They're kind of all learning the same anatomy. Yeah, yeah. So she does, I think it's 14 months, 2.5 years. I think we do like 14 to 16 months there, and the rest is just clinical. And I'm like, yeah. Really? Yeah, because it's like 6 weeks increments, isn't it? Oh, I thought it was a hip rate. Yeah. And before she did, before she came to Southern, she took a year off and was a ER nurse in Kingston. And she said, "What are you doing?" Yeah, I mean, like, I couldn't wait. I don't know if I have the patience. Like, somebody else was coming in, I'd be like, yeah. Yeah, right. It ain't falling right. Exercise science. Yeah. Oh, really? They gotta go. Yeah, something else. Well, that's before we were sold. Yeah. What did you play baseball? My dad played ball in Southern. That was my original post when you get up there. Yeah, when he played, they weren't D1 either. They were like a low level high D2 basically. That's why the same thing with me is I decided I got to USC down to now like all my upper 5 friends that went there, they had already dropped out and went to Southern. They were like, bro, it was fun, but when you realize, man, you're just kind of playing for a minute free tuition, he's like, man, just go have fun. So I was like, I don't even think I'm gonna try it out. Yeah, just like 2 deal. Yeah, so I'm originally from Wichita, and then I graduated high school. I went to my freshman year because my uncle was a superintendent in County, right next to Chatham. That's where I graduated high school. Yeah, I graduated there and I went to Southern. Really? I went south with him because we were in South and he just hired another football coach. It was actually my cousin who was the head football coach for 2 years, fired him. And then, the only reason he got hired was because his dad was superintendent. We all knew that. I was like, Judge, come on. But anyway, he got fired, and we got Coach Clark out of Howard County. And I know I gotta let you do that. Out of Howard County. And then 2 years later, we got another coach. I was like, hey. And can't run 2 nickels together. Yeah, they something else. Was it Glenn Academy? Yeah, Warner Robins High School actually had a nice team. They wouldn't stay 2 years.
So he knows you're an awesome.
I had 70 friends that was in You ever heard that private military school out there? They had high school, they were paying $30,000 a year. But anyway, man, good talking to you, and I'll see you Thursday. All right, yes, sir.
All right, so we're going to talk a little bit about the biogenesis system. I think compare spermatogenesis to oogenesis. Okay, spermatogenesis, unlike oogenesis, starts at puberty and continues until it dies. So we're producing sperm, guys, as long as we can. With Robert De Niro, 80-something years old, his girlfriend just had a kid. And he made her take a paternity test, so he didn't think he could get her pregnant. If I'd been her, I told him to go to hell. He didn't think more than that. I told him to go to history. So we have this spermatozoid up here. That produces, with a real slow, real short version of this, you don't really need to have ever seen it. So we produce a primary spermatocyte. Primary spermatocyte divides into secondary spermatocytes. Then each secondary spermatocyte divides into spermatogenic. we go from a haploid number of chromosomes, 46, to a diploid number of chromosomes, 36. And then we have the sperm cell. These are not functional sperm cells at this point. This is what gets excreted into the lumen of the seminiferous fetus. Our control of gramatogenesis. Hypothalamus in your brain secretes what's called gonadotropin-releasing hormone. Gonadotropin-releasing hormone tells the anterior pituitary gland to secrete follicle-stimulating hormone, FH, and luteinizing hormone, LH. FSH tells the Sertoli cell to start gramatogenesis. LH tells the Leydig cell to make testosterone. Now, this is a self-regulating system. So, Leydig cells also produce testosterone, and they tell the Sertoli cell to undergo gramatogenesis. So, you have two layers of signaling to determine gramatogenesis. So, with that said, as guys get older, testosterone levels drop. It's normal. It's supposed to. So, sperm count goes down as well. Like right now, you guys are almost 80 in your 20s. Sperm count, 2 million a shot. As you get older, dropping down to 750,000 or 500,000 or 300,000 400,000, 500,000 might not be unheard of. So getting someone pregnant as you get older, the chances do go down, but you still can. That's why whenever they have these places they do sperm donation, they don't want guys in their 50s, they want guys in their 20s. That's why. But the testosterone also tells the anterior pituitary gland if it's too high to stop doing this. And even further, goes up here and tells the hypothalamus to stop making this. So it's a self-regulating system. Then there's some Sertoli cells also produce what's called an inhibitor. So if the sperm count gets too high, it will also kind of slow down the anterior pituitary gland, releasing LH and FSH. So now some of y'all are thinking, okay, well, ladies have FSH and LH. Yes, they do. Absolutely, we have the same hormone as women do, in fact, differently in men than do in women. All right, so here's what I just talked about, all written out for you. And here's just a picture of this cross-section of the seminiferous tubules and how the gramatogenesis eventually makes the spermatozoids into the lumen. That's how they make their way out. Then you have the Leydig cells out here. They're producing testosterone. It does not enter the seminiferous tubule. That's why a vasectomy will not interfere with testosterone production. And what happens, and somebody always asks this, if a guy's had a vasectomy, the sperm doesn't just back up until something explodes. What happens is the body will just get space in the vas deferens. The body will just get so you're not going to have any problems down the line, anything like that. Everything works normal, you just can't get someone pregnant. All right, here's a little bit of just kind of a did you know, then we'll circle back up here to the rest of it. So, gramatogenesis, 72 minutes. Takes that long to sperm become mature. And everybody always asks me, what you ejaculate? You don't ejaculate all your time. You don't ejaculate any sperm that's in the test. It's just what's in the seminal vessel. Now, this is something y'all might want to take note of. We'll stay viable for about 5 days inside the female reproductive system. And they're just small little facts, right? I'll just point that out. So about 1,500 seminiferous tubes. If you cut open the kind of pick up with oogenesis. So I believe somewhere in here is where I left off. So we have the primordial germ cell. Here. So we have the oogonia right here. That makes the primary spermatocytes. Oogonia. When do you ladies form oogonia? You're born with it. Y'all have all of the eggs that you're going to have at birth. Now, is there a chance that you would run out of that eggs? As you live 500 years, what normal reproductive phase you're going to have in 35, 40 years, something like that. You're not going to use up anywhere near all of your oogonia. So you definitely don't worry. So we have our primary oocyte. That divides into two secondary oocytes. Now you see a term over here called polar bodies. So what happens with the secondary oocyte? These are still 46 chromosomes. Now mom gives 23, dad gives 20. So what happens is the secondary oocyte divides into these polar bodies. What happens to see from maturing into four oocytes is the division of the cytoplasm. So when this first meiotic division takes place up here, all the cytoplasm goes over here. You don't get the cytoplasm over here. So when this divides, there's no cytoplasm, so the cell is done. When the secondary oocyte divides, you're reducing the chromosomes from 46 to 23. But all the cytoplasm goes to one cell. So the other cell is done. So you end up having what are called three polar bodies, which are useless in anything at all, and one viable oocyte. If not, you ladies could have potentially 4 children every time they get pregnant. Now, sometimes this doesn't happen perfectly, and you may have to. This process happens one time a month from the time you start puberty till the end of menopause. So 35, 40 years, somewhere like that. So it does, you're not going to run out of oocytes. And I talked about that last week, if I remember right. Because the follicles that they grow in generate something called the corpus luteum. And then eventually the corpus albicans. Corpus albicans occur when you don't get pregnant. And that corpus albicans, you can do a cross-section of ovary, and you can count how many of those there are, and you can see how many times they are. And here's just a comparison of the two. So, biggest thing I want you to know right here. No polar bodies on this side right here. So, primary spermatocyte will eventually yield 4 sperm. You have the haploid division, and then the diploid division right here. I got to put a picture of that in your second. So, you're reducing from 46 to 22. Now, if for some reason this haploid division doesn't take place properly, so you have a sperm or an oocyte with 46 chromosomes. Can that oocyte still be viable? Can that sperm still be viable? Yes, no? Yeah, absolutely. And what will happen is you will have a baby born with 69 chromosomes. And for the most part, unless someone does genetic testing on you won't know anything about it. There may be somebody in this room with 69 chromosomes. Unless you do 25th, 23andMe or something like that. You'll never know. Because it doesn't cause any problem. Generally. So, I mean, sometimes it is, generally. So just be aware of that. Whenever you training some joint or something like that. And then you have, of course, fertilization. So here's the polar body hanging out. Arnold Schwarzenegger made a movie one time, years ago, with James DeVito, where Schwarzenegger was, perfect, heavenly body, or whatever. And DeVito was left there right. DeVito came from the polar body. Alright, so there's just a little picture of it. And I put 2 or 3 pictures of this in here for you. And so there's a note showing how we have the first and then the second meiotic division, so we're reducing chromosome. Okay. Alright, so ovarian versus uterine cycle. Are they the same? Is the ovarian cycle the same as the uterine cycle? They do mirror each other some, but no, not at all. So here is a comparison of the two. So here we have the first day of menses. That is actually the beginning of the uterine cycle, as well as the menstrual cycle. So the first 7 days or so, the old endometrium is dying off. That's what causes men's blood loss, so we don't talk about it. So beginning 7th day right here, thereabouts, you go through what's called the follicle, where the endometrium is growing and growing and growing and growing. Then we have, up here, we have the same thing happening with the primary oocytes in the secondary. Then we have ovulation taking place there approximately 14 days. Now, ladies, your body temperature will increase slightly during ovulation. You need a pretty good thermometer to take it. One get a glass when mom had it little. They generally aren't accurate enough to tell, but the digital ones can. So then you have ovulation taking place. Then the follicle at this point becomes the corpus luteum. And that produces hormones that continue to cause the endometrial tissue to grow and grow and grow. Now, if fertilization does not take place, or implantation does not take place, then eventually that corpus luteum dies off and becomes a corpus luteum. And you quit supplying the endometrium with the proper hormones to grow. And it dies off and you have no baby. If you get pregnant, you secrete a hormone called HCG, human genetic growth hormone, that keeps the corpus luteum producing progesterone, which is what stops menses. And progesterone will keep this growing until the baby forms the placenta, and then the placenta will take over. But that takes a couple of weeks. And if there's no placenta, then there's no HCG to keep it going. Now, let's look at our hormones. So that FSH right here, in the beginning, kind of triggering all this. And you can see FSH kind of starts dying off. Then we have luteinizing hormone, LH. LH is what triggers ovulation. So LH is also what makes us produce testosterone. So then after ovulation, you don't need more, so they both kind of raw. Now we have ovarian hormones. So initially the ovaries are making, causing all this to happen. Causing some of this to happen. And then after ovulation, you start producing progesterone, which maintains this and maintains this until either you get pregnant, in which case you keep producing progesterone, or you don't get pregnant and progesterone levels drop off. And then the menses occur again. Now, any time in this area right here, you ladies can become pregnant. Remember, sperm stays viable for about 5 days inside your reproductive system. time things here, and this is none of my business. But if you are trying to time things, just remember, and I would be on the safe side, I would even start being a little more cautious back over here. And even though it could be here, you really don't want to be pregnant, I'd be a little more cautious there. I've had patients who came to see me, had been for years, start working with the safe, gets everything going, now they have out there. And I want to take the shoes away from delivery. That's okay, they don't want to get it. So she got pregnant, after about 6 weeks of seeing me, she started having a menstrual cycle after about 3 months. She was like, I told her, better start doing it. I don't think she cared. I don't think she 100% believed she just came in about 3 months later. I'm pregnant. And her attorney, I don't know, they got it. All right, so there is how the hormone affects this, and now, why? Some of y'all may have friends that are trying to get pregnant, and one of the things these women are doing is taking their temperature. So you can see right here, how you stay at 96%, 98, or 30. So we get up here to ovulation, and you see how there is a slight increase in body temperature from 38.4 to 38.7. Now, the last thermometer that John gave you something in your kid probably not that. Even the one that you put on your forehead is probably not going to be that. The digital one, but that's just also something that you can find. You will hear women talk about how they do cancer and all that. I wouldn't necessarily base a whole lot of stuff on that little bit of change right there. Then, if you sit out in the sun, you might have just a little change because you sit in the sun. All right, so we have the phases of the reproductive cycle. Post-ovulatory, secretory phase. The first 14 days, and then the last 14. Now, do you all know how the calendar used to be set up? It used to be 30, 31 days. It used to be 28. And it was based on female reproductive. Is where they came up with 28 days. In fact, the female reproductive cycle, they used to be termed that they were associated with lunar. You want to look them up, you can. I don't know. But here you have the hypothalamus. So, right? That's where the gonadotrophic hormone, the release hormone. Pituitary gland excretes LH and FSH. Okay? Gonadotrophic release hormone, hypothalamus, controls the ovarian and uterine cycle because it tells the pituitary gland to secrete these two hormones from the anterior portion of the pituitary gland. Pituitary gland has an anterior posterior portion. Posterior portion is more like storage. Anterior will secrete hormones. So this will start to release the front. And then LH will trigger the ovarian follicle, make full amount of estrogen. That's what triggers ovulation. And so there is our the function of the hypothalamus and pituitary gland. Now, fertilization. I kind of talked about this a little bit. But most of the time, fertilization takes place out here in this area. And then the fertilized zygote makes its way up through the uterine tube and undergoes different cell division until it becomes the morula. And the morula is actually what tends to the plant. So, fertilization takes place out here at day 14. It's not until day 21 or 2 So there is a period of time there where you don't know the fertilization takes place. Now, you're all familiar with these pregnancy tests where you ladies go home and you be on full step. Some of those tests can detect DHCG at 24 to 48 hours after fertilization. But they are terribly, terribly accurate. They get false negatives all the time. You can't really depend on anything until the actual implantation takes place and you have some contact with mom's blood. So that's why a doctor's office wants you to do the pregnancy test until you're at least 2 weeks, usually 2 weeks on from because the pea sticks are not there yet. Yeah.
So you do the, when you were adjusting it, that first time, or you adjust it, during the.
Oh, I've been seeing her, I saw her a few years.
You just kept the whole pregnancy.
She had a pretty nasty sacral subluxation. It was interfering with the parasympathetic nerve supply, which is also part of it. We don't talk about it here. We'll get that in your hand. But we, the parasympathetic nerve will actually help signal the ovaries and the uterus to start moving. It's not totally hormonal. There is a neurological. And that's why working with the sacral got the parasympathetic nerve supply to start working. All right, so kind of thank you for the question because I'm going to actually piggyback on this. So, if you're stressed out, your sympathetic nervous system is on overload, right? So the sympathetic nervous system will shut down reproductive function. So say you come up, today is the day you're supposed to start your menses, and you don't. And you haven't quite been as careful Saturday night, you should have been. So you're not having your menses. First thing, all your girlfriends tell you, ladies, don't stress about it, right? They are absolutely right. Don't stress about it. Because an increased sympathetic function will actually override the parasympathetic nervous system and will actually cause to be delayed. You may not be right. The more you worry about it, the longer it's going to take to have it mixed. Because you're in a hypersympathetic state. Now, you will still eventually have your menses, unless there's some kind of problem with something. But it may take an extra week or so. And that's why you love it. Or you count the days on the calendar. So whenever your friends tell you not to worry about it, they're absolutely right. And all of you know what I'm talking about. We've all been there. Some of us guys have also been there. So hopefully you can talk enough over in that situation, think enough over to be interested in something like potentially happens like that. So anyhow, the more you can stress about it, the longer it's going to take. Now eventually it will happen. Unless there's some sort of mechanical problem going on. It won't. But worrying doesn't happen. During finals, most of you don't have this because of the stress of finals. Very common. And y'all figure what this is your second quarter, so y'all heard out at the same time. At some point, you will. You ladies will all be pretty close unless you're taking birth control. You'll all be on the same cycle more or less. And there'll be one of you that is the alpha female. And everybody else will follow her. So at some point, all of you will be pretty much on the same cycle. Takes a little while. They say it's back in 50 again. And put them on there. Nobody's going to work control, nobody's pregnant. So put all these women together, and within a few months' time, they were all on the same cycle. They bring in the midnight and follow her within a few months. She's on the same cycle as everybody else. Hormone control. So we have an anatrophic releasing factor, the glycoguide, FSH, or the glycoguide, LH, the glycoguide, the adrenal gland, but it has no effect unless it's really out of control. That makes sense. All right, so estrogen helps the growth. Now, you guys do have estrogen in your body. Your adrenal gland produces some estrogen. Very low levels. However, you can make that worse to the point it actually will interfere with testosterone. It will fight for the same receptor as testosterone. A couple things that will cause it. Plastic water bottle. So you take that plastic water bottle, set up there in your car this afternoon, it's going to be needed. The estrogen in that plastic will leak into the water. So that's why, you know, you don't see a lot of plastic bottles. Also, almost all plants have estrogen in some degree. Certainly soy, things like that have a lot of estrogen. So you got that. Plus, body fat produces estrogen. A lot of times that's what will kick off a young lady's menstrual period. When they start getting a little more body fat on them as they start to mature. And it's normal because women store fat differently than we do. And that's usually what kind of kicks off their menstrual period. But fat produces a lot of things. So you see somebody that's really, really overweight a lot of times with guys, they'll have kind of almost feminine feet. And they will start developing, bad enough, they will start developing breast tissue. We have a little bit of breast tissue. Not many, but we have guys that are really overweight and to produce more estrogen, they call it breast tissue. And we'll run it before that's the effect. That's not it. Then we got progesterone. That's kind of what's in a lot of birth control pills. The idea being tricking your body into thinking you are pregnant. So you know oxygen. Now birth control pills, I'm going to say this and I'm going to leave it alone because they're my business, what y'all do. Birth control pills prevent you from having a menses. I'll say you won't have a menses for 3 or 4 months. If any of y'all are using them, you might want to kind of reconsider and talk to your doctor and reconsider what you do. I know a mention is aggravating. I can't lie, I don't know. I know how it is. I have this fun. I don't know if I can imagine it being that.
I do use spring.
I used to use spring. Sorry.
Especially the non-hormonal.
They basically want one they put a but progesterone, what it does is you don't have a menses once a month. That endometrial tissue just sits there and keeps growing. Not grow small, they keep growing. And endometrial tissue is just one step above a stem cell. So it's highly proliferated and poorly differentiated. So that tissue hasn't decided what it wants to do with that. And so it's more likely that tissue will actually have some sort of hiccup in DNA replication. And because it grows very rapidly, that hiccup can very quickly become something you don't want. Now, if you have them all the time, but you have it on mention once a month, you can. That tissue is only there for a couple of weeks, you're going to excrete it, so who cares if there's something wrong. But if it sits there for 2 or 3 months, they have a chance to actually develop into something that you're more concerned with. And so your likelihood of developing uterine or cervical cancer goes up considerably with those pills. In fact, I don't know that most doctors prescribe those anymore because it is so much more risk to have having problems with uterine cervical cancer. Now, as you ladies go, this drops off as well. As part of menopause. So menopause is not. So it's some more density size. If not, the more time that you have this whole growth of the endometrium and the sloughing off of the endometrium, you don't get rid of all. A little bit of it will stay behind. Get rid of all. So the more times that happens, the more likely it is for that tissue to have a hiccup in the DNA replication and start growing and become something more serious. So that's why as you get older, you go through menopause and prevent that from happening. Not only with uterine tissue, but with breast tissue. The estrogen causes growth of breast tissue. And that's not even so that you have a problem with most. The more of the tissue that has a part inside of one that really has growth, the more likely it is for something to go wrong and to magnify. That's when you get into the HRT. So say you're 60 years old and using the hormone receptor. That's why your risk of uterine and breast cancer go up exponentially because of those increased levels of hormones that are abnormally high. Guys have the same thing. Because the prostate gland is under the influence of testosterone and a few other things. Just part of the testing. So testosterone placement is good. You do run the risk of having something bad develop in those organs. Now here again, it kind of goes back to your personal decision being the doctor. Is the risk for it? That's the decision that you make as a personal decision. So if you're going to do that, I'm not saying you're not to do it. Maybe it's a good reason. But you need to monitor what's going on. Like you guys, because of my stroke, I'm using testosterone replacement therapy because it helps regenerate hormones. And but because of that, we monitor my prostate gland and make sure it's not cortisol and a few other markers every 3 to 6 months. Your prostate gland produces an enzyme called prostate-specific antigen, produced by the surface of the prostate. And if the prostate gland gets bigger, you produce more of that antigen. It's a very simple concept. So you test the levels of that, and if it gets above a certain level, then it can indicate the prostate has gotten larger. Now, it may not indicate cancer. In fact, you don't think it does. It just indicates the prostate has gotten larger. The prostate gland is encapsulated. So when the prostate gland gets larger, so the prostate gland starts swelling. So you have this void right here. Prostatic gland. So the prostate gland, because it's encapsulated, doesn't swell out, but it swells in. So that's why guys have trouble urinating if they have large prostate. I think I mentioned that we were talking about urination, but that's why. Now, just because their prostate is large doesn't mean they have cancer. In fact, most of the time it doesn't mean that. As you get older, a little bit of prostate enlargement is 100% normal. Because we may decrease testosterone levels, but we don't stop producing our estrogen. Testosterone levels dictate growth hormone. And yeah, I don't have growth hormone levels you guys got. I can't go to the gym and put on 20,000 muscle in 6 months or easy. I could make 20,000 muscle all my life. But so it does drop, but we still produce something. And I want to make you with that too, with training the guy. A lot of this stuff, we talked about circulation. A lot of this stuff will end up metastasizing with cancer cells, with different parts of the body, will metastasize to the wrong part of the body. I've had patients with prostate cancer metastasize to one part of the body. I've had patients with colorectal cancer metastasize to one part of the body. I've had patients with uterine and cervical cancer metastasize to one part of the body. And they came to see me first because it called their back. And the real kicker is it doesn't show up on the clinic domain, not till it's pretty well advanced. And it can do one of two things: it makes bone dense, make it wider, or it can be thrown away and make it less system. But you don't see that until there's about 30 to 50 involvement of the company.
Which is more common deterioration or?
Okay, take one after the other. I don't know if there is one, I'm sure if I look it up, you find there's one, figuring out one. So it kind of depends on your individual, design. But the reason point, I guess I kind of got off track with that, the point I'm trying to make is, when you take the case history, it seems silly to ask some of these questions. But you back. A woman who is experienced menopause and still having vaginal bleeding, you go to the ER and you go to the ER right now. There's nothing you can do. There's a very simple test, PSA test, you can send this patient an accident, very, very simple. And if they have prostate enlargement, you do can treat it for that. But you need to make sure they also see at least their MD, their primary MD, or their oncologist. But unfortunately, you can be a primary care physician as well. So, can I treat prostate cancer? Absolutely not. But do I get to send them to? That's what I do more about it. But if I don't, guess who's going to come back? And not just illegal